Hello, hi everyone, welcome back. So today in this video lecture we'll be solving this problem valid anagram. So in this problem we are given two strings s and t. We have to return true if t is an anagram of s and return false otherwise. So what is an anagram? Anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. That means we're given a string t. T is an anagram of f if T can be obtained by rearranging the characters of the string S. If it is possible, then T is an anagram. If it is not possible, then it is not an anagram. Let's take the example. So let's take this example. Let's say we have anagram, the word anagram. So this is the word that we have. And this is the string S, right? The string T is, let's say, N A G A R A M. I want to check whether S and T are anagrams. Means T is an anagram of S or not. That means all of the characters which are there in S must be there in T. So A, N. So A occurs 3 times in S and A occurs 3 times in T as well. N occurs once in S, N occurs once in T. Fine. Now, G occurs once in S, G occurs once in T, R occurs once in S, R occurs once in T, M occurs once in S, M occurs once in T. That means all of the characters are exactly identical in number and form. That means S and T are anagrams. And the answer for this test case is yes or true. So, the answer is true. Let's say this is K. We have K here. So in this case, we can see that K is here in this T while this K is not there in this S. That means, what does that mean? That means these two strings are not anagrams because K is here which is not here in S. So the answer for these two test cases, this test case is false, right? So that's all we have to do. So how we can solve this problem is easy. All we have to do is to just count the characters here. The number of times every single character occurs in the string S. If that count is same for the same character in the string T, then that means these two strings are identical or anagrams of each other, otherwise they are not. So to do so, what we can do is to count the frequency. We can see that we have only lowercase letters in the strings S and T, and we have 26 lowercase characters that are there from A to Z, small a to small z. That means we can take an array where for every character we have a particular index. For A we have 0, for B we have 1, for C we have 2, and so on. So for A we have 0, and this is the frequency array or the count array where we'll be counting the frequency of each character given in the string S. So let's count the frequency of A. The frequency of A is 3 because A occurs 3 times in S. So the answer is 3. N occurs once, so N is 1. So N may be somewhere here, so N is 1. G occurs 1, so let's say 1. R occurs once, so let's put 1 here. Is there M occurs once, so M occurs once. So that means we have the frequencies of these characters, right? Okay, they are not at the right positions. I'm just putting them in the order. Means A appears before M, so I'm putting A here, M here, and so on. Then what we can do is we can traverse the string T and we can do the same for T. That means what we can do is we can count, we can check if the frequency of that particular character matches with the frequency which we have here in the array. So n is here. Is there n here? What is the frequency of n? It's 1, right? So that means we cancel it. It becomes 0. Then we move to the next character, which is a. What is the frequency of a? It's 3. So we decrease the frequency by 1. It becomes 2. Now we move to the next character, which is g. What is the frequency of g here? It's 1. So we decrease it by 1. It becomes 0. The frequency of a is again a appears. That means we decrement it by 1. It becomes 1. Then we move again to the next character, which is r, and again the frequency we decrease it to 0. Now we again move ahead, and now we again move ahead to k, right? And we decrease. So we are here at a. We again decrease the frequency of this a, and we make it 0. Then I move to k, and let's make the frequency of k to be 0, right? So that's my final array. The final array contains 0 for all of the characters. That means the given for the given test case, so it's not k actually, it was not k, it was it was m, right? It was m. So for m the frequency so the final array contains 0 for all of the positions. That means these are valid anagrams. So the answer for this test case is true, right? If we find any position with the non-zero value, that means these strings are not anagrams, and we return true in that case, right? So that's all we have to do in this problem. Let's jump to the code implementation part. So is anagram, and let's take a frequency array. Let's iterate over the string f. Let's count the frequency of each character which is there in this string. Let's decrement the frequency of each character. T f of it minus a minus minus. At the end, what we have to do, we have to check whether all of the positions if f of I is equals to 0, then we return false. We return if f of is not equal to 0. If we find any character which has non-zero frequency, then we return true, then we return false. Otherwise, at the end we're gonna return true, right? So that got accepted. Let's submit it. So we submitted it, and that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel. We'll see you soon in the next video. Till then, take care. Bye bye.